Lesson 20 is about volume. The volume of a geometric solid is the number of cubic units that can be contained in the solid. Volume is always measured in cubic units. It's important to remember that units are used for length, square units are used for area, and cubic units are used for volume. The volume of a right solid is equal to the area of the base times the height. So this is the general formula for any right solid. Okay, we're going to get our next page up here. This is a triangular prism. Okay, and it's called a triangular prism because the base is a triangle. Okay. And it's an isosceles triangle here. It has a base of 4. This is the height of the triangle. It's not the height of the whole solid shape. It's this height right here, okay, from the tip down to here. This is the capital H, however. This is the height, the large height. I'm going to get a bigger, thicker line here. Okay, so that is the height of the whole shape. So we're going to write the general formula. Volume equals area of the base times the height. We're going to plug in the formula for a triangle since that's our base, and we're going to multiply that times the height. The base and the height of the triangle are 4 times 8, and we're going to divide that by 2. And the height of the whole shape, we're told in the problem, is 6 centimeters. I don't know what went on there, but something funny happened. So we're going to multiply it by 6. 4 times 8 is 32. 32 divided by 2, then times 6 is what we've got, the height of the whole shape. And 32 divided by 2 is 16. 16 times 6 is 96, and it's in centimeters, and that's our answer, 96 square centimeters. Okay, number 3, the base of a right prism 8 meters high is shown. Find the volume of the right prism. Well, this is a trapezoid, and there are 3 ways to do trapezoid. One is with the trapezoid formula. The other is going corner to corner, making a diagonal through it and doing it as 2 triangles. I'm going to do this as a right triangle and a rectangle. So I'm going to write down volume equals area of the base times the height. Now the area of the base, since it's a composite shape, is made up of a rectangle and a right triangle. The rectangle formula is length times width. The triangle is base times height divided by 2. Well, I know that this entire length from here to here is 10. I know this part has to be 4 because opposite sides in a rectangle are always equal. 10 minus 4 then will give us the length of the base of the triangle. And the dotted line, since it's a right triangle, is the height. That's an opposite side in the rectangle, so that is 6, and we have all of our dimensions now. So length times width, 6 times 4, or 24. That's the area of the rectangle. Of the triangle, 6 times 6 divided by 2, that's 18. 24 plus 18 is 42. So the area of the base is 42. We can take that over here to our formula and plug it in. And the height, we're told in the problem that this height right here, floor to ceiling, is 8 meters. Okay? And we're going to multiply that 42, the area of the base up here, times that height, and it's going to be 336 meters cubed. Okay, the base of a right solid is 10 kilometers high. That is 10 kilometers high is shown. We want to find the volume. Again, general formula, area of the base times the height. And again, we have a composite shape, so I'm going to go over on the side and do my area of the base. This time I have a rectangle and a semicircle. The formula for the area of the rectangle is length times width, and the semicircle is pi r squared divided by 2. So our volume now, we're going to figure this out. Length times width, 5 times 6, that's 30, and pi r squared divided by 2 is pi times 3 to the second divided by 2. That equals 9 pi over 2. So we're going to add those two together. You can do this out on your calculator if you want before you substitute it back and get an approximate answer. I'm going to do it in terms of pi. 30 plus 9 pi over 2. We're told that the height is 10. We're going to use the distributive property now. We're going to multiply each thing in the parentheses by 10. 10 times 30 is 300. 10 times 9 over 2 is going to be 45 pi. And you can verify that on your calculator. You don't have to multiply by the pi if you're leaving your answer in pi. And kilometers is our unit. And we put the cubed because we're finding volume. How many cubic kilometers can fit into a right solid of that shape? How many does it contain inside? This problem is a little bit easier because it's not a composite shape. This is the base right in here. Okay, so we're going to write our general formula. Volume equals area of the base times the height. I'm going to substitute in for area of the base the formula for the area of a circle. The circle has a radius of 6. Okay, so I'm going to do pi times 6 to the second power, and the height of the whole shape is 11. Okay, now I have 36 pi, and I'm going to multiply that by 11. To multiply by 11, we write the first numeral first, second numeral last. We add the 2, and that goes in the middle. So this is 396 pi, and again you can multiply this all out and get an answer for it. But 396 pi, and it's in inches, so we're going to put inches cubed because it's volume. And the last one here is really the easiest one of all. There's no shape to look at, but we're told that the base has an area of 52 square feet. So all we have to do is write the formula down, area of the base times the height. We've got the area of the base. We know what it is already. We also know the height. It's 15. And on your calculators, I'll do it here out, but if you have your calculator, you can certainly do it on your calculator. 5 times 2 is 10, carry a 1, gives me 260. 1 times 2 is 2, 1 times 5 is 5. And my answer then is 760 cubic feet. That concludes lesson 20.